Thanks for joining me for another episode. Many of the application vulnerabilities that we see today arise during the design and development phase. In this episode, we'll cover secure coding practices, we'll look at some best practices, we'll talk about strategies for managing your code securely, and we'll explore a simple file upload web application written in Node.js and explore some of the vulnerabilities that can arise during coding, and we'll also fix these vulnerabilities to give you an understanding of how these things work. Stay tuned and I'll be right back. Welcome back and let's dive right into the topic. So, we're covering secure coding today. We're looking at the essential practices for developing safe applications. We're trying to understand what it means to prevent common vulnerabilities through secure coding practices. And then the primary goal here is to equip you with knowledge that you can incorporate in your development lifecycle to prevent vulnerabilities that arise from poorly coding your applications. So, what is secure coding? Secure coding is the practice of writing code for systems, applications, or your APIs and services that ensures that the security and the integrity of those applications remains the same. Ideally, that means preventing vulnerabilities that arise because of poor coding practices. So, what are some secure coding methodologies? Obviously, we mentioned secure design principles in the previous slides. One of the things that we need to understand is embedding least privileges, ensuring that we're designing with defense in depth in mind, we're failing securely, and we're doing security by design within our applications. We can talk about risk assessment and management, where we're identifying and evaluating and mitigating these risks early in the development life cycle. Let's talk about some best practices for secure coding. One of the first things that we can talk about is memory management and the use of memory safe languages. So, for example, throughout the development lifecycle, we're selecting programming languages that are designed to handle memory safely and avoid the introduction of buffer overflows within our application and subsequently leading to vulnerabilities within the application. So, for example, rather than choosing a language like C, which you need to actually ensure that you're managing memory safely, we can go with more newer languages that that have inbuilt functionality and capabilities to handle these safely. And then we can talk about input validation and sanitization.